how to effectively specify non-conventional in Aspen Plus without any error messages. For non-conventionals, in the property environment, the user needs to declare the variable that is providing the name of the component, and I've done that. Then to choose the appropriate solid model to calculate the enthalpy and density of the component. And in the simulation environment, how do we provide the data such as the ultimate analysis, alternate and sulfonate? This is done in the simulation environment. Under the setup file, and we provide the component attributes. Other examples of non-conventional components are plantain peel, rice bran, and we shall take a look at this problem to add the component attributes to the non-conventional components. Blending Groundnut Shell and Corncob, and the question is, using Aspen Plus, simulate a mixer unit operation to blend the following solid biomass components: Groundnut Shell, Corncob. The mixer should operate at a temperature of 120 degrees Celsius and at a pressure of 1.5 bar. Each biomass stream enters at 25 degrees Celsius, 180 m. Then the mass flow rates are: the Groundnut Shell should be 50 kg per hour, and the Corncob should be 40 kg per hour. Using Aspen Plus, simulate a mixer unit operation to blend the following solid biomass components. Here is the simulation environment. We can see the properties environments, the simulation environment, safety analysis, and energy analysis. I'll be sure the simulation is highlighted in the pane. Now the question says, we need a mixer which can be found in the model palette. Then I will hide the materials. Since there are two separate materials being fed into the reactor, the user is required to create separate stream for each. For Groundnut Shell, since I don't have any conventional components being fed into the reactor, I wouldn't need to specify any component in the mixed stream. Then what am I to do? We can find it out that it can be found out that the NC tab and the CI solid tab is left deactivated. For me to have the non-conventional components specified in the simulation environment, I need NC solid to be activated. Then what next? In the simulation navigation pane at the left-hand side of the screen, we need to specify the non-conventional solid by clicking on the triangle pointing at the setup. Then I will choose the stream class. Conventional has been specified as a global class for the simulation. In that case, I need to specify a substream. Then we click on the stream class. Since conventional has been chosen as a global class for the simulation, under the substream, we will have the mixed is selected. That is, this is the stream class for the component. This mixed handles conventional components which participate in phase equilibrium. Now I need to specify the non-conventional. When this is done, the non-conventional will be taken as the substream. In my next video, I will explain and expatiate on the streams and the substream. If that is done, then I will go back to my flow sheet. Automatically, the NC solid tab is highlighted. Click on the NC solid. NC means non-conventional. Substream name NC solid has been chosen. At what temperature? No temperature was specified. So let me choose 25 degrees Celsius room temperature. The mass flow rate of the component is 50 kg per hour for Groundnut Shell. Then the mass fraction, I'm using the mass fraction, that is all of the Groundnut Shell. Wetness, the user will be expected to specify the component attributes. Then we come down to the component attributes. We can find groundnuts and the Proximate. For me to be able to simulate this effectively, I need a Proximate analysis. The Proximate analysis will be taken from Olufunke et al. 2025. The Corncob and the Groundnut Shell, the pH, moisture content, volatile matter, ash content, and fixed carbon as be given in the table. So I need one of these to be filled. The moisture content of the Groundnut Shell or the fixed carbon, the moisture content, the fixed carbon, volatile matter, and ash. So the moisture content of the Groundnut Shell is 4.47%. The fixed carbon is 72.07%. The volatile matter is 6.76%. And the ash is 16.70%. While the Corncob, the moisture content of the Corncob is 6.36. This carbon is 60.06. Volatile matter 1.85, and the ash content 31.19. So for the Groundnut Shell, the moisture content of the Groundnut Shell is 4.57 expressed in mole. It does be 0.047447. The fixed carbon is 0.72. Volatile matter is 0.06748 approximated, and the ash content is 0.16 or 17. It is not compulsory for the user to enter all the attributes. To specify one of the attributes is enough for the calculation. Now I need to specify the octanol for groundnut. So blend the Groundnut Shell and Corncob. The approximate analysis of the components is given in Olufunke et al. 2025, while the sulfonyl and octanol is given in the table below. The octanol, the Groundnut Shell is 46%, and the sulfonyl is 1%, and from Corncob 42% and 8%. For the octanol, for the Groundnut Shell, I have 46%. That is the carbon composition, and organic matter for sulfonyl. So for the carbon That's be 0.46. And that's be enough. Is math correct? So then I will click to choose the softener. For the softener, that's the organic matter is 1%. That is organic matter, and here it is organic matter is 1, so that is 0.01, and that's fine. So next, that is the fourth material input. That is the second stream. I mean this. This is the fourth, the second stream. So I need to specify that as well. Click on the non-conventional solid. Then next, all required input is complete. You can run the simulation now or enter more inputs. To enter more inputs, select cancel, then select the input you want from the simulation pane. Let me get this right. I have a computation order for the flow sheet B2. There's a warning error on B2. Of course, I've not specified some other things for B2, but it has converged, of course. Something is missing. The mixer should operate at 120 degrees Celsius. That is, the pressure is 1.5 bar, and at 120 degrees Celsius. Then next. Okay. So fine. It has converged. You can see below the screen at the left hand corner the results are available. And that is all. So then you can run again to see, to be sure. This is how to specify the non-conventional properties and their attributes effectively on Aspen Plus. Activity. Question number 1. Which one of the following type would you choose for a component like sodium chloride salt? A. Conventional, B. Solid, C. Non-conventional, D. Option A or B, depending on the process type. Question number 2. A solid containing a composition different from the user's defined data composition should be chosen as type dash. A. Pseudo components, non-conventional and solid. Question 3. Prominal in Aspen, what does this term mean? Proximity analysis, proximate value of solids, property for mining components, and all of the options given. Question number 4. This component does not involve in-phase equilibrium in Aspen Plus. Solid, conventional liquid, non-conventional solids, conventional solids. Question 5. Aspen Plus is now getting interesting to me. Yes, not yet. I need to learn the basics. Not really at all. I used to be skeptical about equation-oriented model, activity coefficients. Then, what do you understand by pseudo components? Comment, ask questions, and let's connect. Like, share, and subscribe to get notified for more.